Welcome to Review and Preview Problems 1078 to 1084 in the CCG book. For each diagram, 1078, for each diagram below, write an equation to represent the relationship between x and y. When we look at A, x and y are alternate interior angles, so our relationship is x is equal to y. Looking at letter B, we have an inscribed angle, which is x. We have a central angle, which is y. So our inscribed angle is half of our central angle, so we can say x is equal to half of y. Or we could write it the other direction and say our central angle is double our inscribed angle, so 2 times x is equal to y. When we look at the circle in problem C, we can set up a proportion 3 over x, talking about these two pieces, is equal to 5 over y. Then when we cross multiply, we can say that 3 times y is equal to 5 times x. When we look at the circle in example D, we can see that both of our angles, our inscribed angle, are both connected at the same point, so we say that x plus y are equal to 180 degrees. 10-79, for each triangle below, use the information in the diagram to decide if it is a right triangle. Justify each conclusion. Assume the diagrams are not drawn to scale. Well, looking at this triangle in letter A, I know that 64 plus 26 plus x should be equal to 180. So when I subtract 64 and 26, I get x is equal to 90 degrees. So this is a right triangle. Looking at letter B, I have 3 sides. I can assume my largest side is my hypotenuse, so I will square both of my legs, 8 squared plus 15 squared, to see if it is equal to 17 squared. And if I have 64 plus 225, that absolutely is equal to the 17 squared, which is 289. So yes, this is also a right triangle. 10-80, a cement block is the shape of a prism with the length of 1.5 feet. So if we draw a cement block, like the book asks us to, the length is 1.5 feet. The width is 1 foot, and the height is 1 foot. Centered on the top of the block and passing all the way through the block are 2.25 feet by 0.2 rectangular holes. Draw a diagram of the block. So I have the diagram drawn to the right. What is the volume of the block? So to find the volume of the block, we can do 1.5, our length, times our width, times our height. So the volume of the entire cinder block is 1.5 feet cubed. But then we need to subtract out our hollowed rectangular holes. So if we take 0.25 times 0.2 times the height of 1, and we multiply that by 2 because there is 2 holes, we get 0.05 times 2 for both holes gives us 0.1. When we subtract that, so we need to take our entire cinder block, subtract out the holes, the volume of this cinder block is 1.4 feet cubed. 10-81. A spinner is divided into two regions. One region, red, has a central angle of 60 degrees. The other region is blue. So if we sketch a picture of this on our paper, we have one region that is 60 degrees, and that is red. The other region is blue, which would be 300 degrees because we're talking about a circle. If the spinner is spun twice, what is the probability that both spins land on blue? So if we look at our red piece of our circle, 60 divided by 360 would be 1/6. So we would say that red would occur 1/6 of the amount of times and blue would occur 5/6 of the amount of times. So we're going to take the probability of spinning blue, which is 5/6, and multiply that, which gives us 25 over 36, or 69.4% of the time, we have a good chance of spinning blue. If the radius of the spinner is 7 centimeters, what is the area of the blue region? So we can find the area of our entire circle by taking pi r squared. So pi times 7 squared gives us 49 pi. And then we only want 5/6 of the circle, so if we multiply that by 5/6, that gives us approximately 128.28 centimeters squared. A different spinner has three regions: purple, mauve, and green. If the probability of landing on purple is 1/4, so if we draw our diagram and mark off our purple, that is 1/4. And then 2/3 is mauve. So purple, mauve, and then our last area is our green region. So it wants to know what is the central angle of the green region. Well, to figure out what portion of our spinner is the green region, we want to take our whole spinner, we want to subtract 1/4, which represents the purple area. We want to subtract 2/3, which represents our mauve area, which after we find a common denominator and combined all of our like terms, so our common denominator would be 12, so we have 12 over 12, multiply numerator and denominator by 3, so minus 3 over 12 minus 8 over 12 gives us 1/12. To find that central angle, we want to multiply that 1/12 by 360 degrees, because that's what our entire circle is, and 1/12 of 360 degrees gives us a 30-degree angle. 10-82. After doing well on a test, Aletha's teacher placed a gold star on her paper. When Aletha examined the star closely, she realized that it was really a regular pentagon surrounded by 5 isosceles triangles, as shown in the diagram below. If the star has the angle measurement shown in the diagram, find the sum of the angles inside the shaded pentagon. So to find the interior angles of a regular pentagon, we can divide this pentagon into 3 triangles, each equaling 180 degrees, which would tell us that the sum of all of the angles inside the shaded pentagon would be 540 degrees. 10-83. Remember that a radian measure of a central angle of a circle is the ratio of the arc length to the radius. What is the radian measure for a 45-degree central angle on a circle with a radius of 5 centimeters? What is the radian measure for a 45-degree central angle on a circle with a radius of 1 centimeter? Answer in terms of pi. So when we are trying to figure this out for problem A, the very first thing that we need to do is we need to determine the circumference of our circle. So we use 2 pi r to determine the circumference, or the length of our outside of our circle. So when we replace this r with a 5, 2 times 5 pi gives me 10 pi. I then need to only take the portion for this 45 degrees. So in order to figure out what that is, I'm going to take 360, divide that by 45, which gives me 8. So I'm going to multiply the circumference by 1/8 because I only want 1/8 of my circle. So I get 10 pi over 8, which reduces to 5 pi over 4. And then remember, we want to set up a ratio. So 5 pi over 4 is the arc length. And then we want a ratio with our radius, which is 5. So if I write this a little differently, 5 pi over 4 divided by 5 over 1, I know that I need to change my sign to multiplication and flip the location of my 5 and my 1. I now can cross simplify. 5 over 5, if we multiply straight across, cancel each other out. So I get pi over 4 radians. So likewise, we can do the same thing for a circle with a central angle of 45 and a radius of 1. So 2 pi r, we get 2 pi. Our central angle is 45 degrees, so we want to multiply that by 1/8, or divide 2 pi by 8. So we get 2 pi over 8, which reduces to pi over 4 radians. So our answer in terms of pi for a radius of 5 centimeters or a radius of 1 centimeter is the same. Letter B says, the central angle of a circle has a radian measure of pi over 3. What is the measure of the central angle of the sector in degrees? So remember, our radian measure is equal to the ratio of our arc length over our radius. To find our arc length, we can take that a step further, and we can do 2 pi r times x over 360, if x is our central angle, and then we want to divide that by our radius, which is r. So we can now plug in the information they gave us, pi over 3, set that equal to 2 pi rx over 360 all over r. So if we simplify what is on this side of our fraction first, 2 pi rx divided by 360, looking at it, r divided by 1, we change using our inverse operation and move our 1 and our r's location. We can cross simplify our r out, so we now are looking at pi over 3 is equal to 2 pi over 360. So at this point we cross multiply. 6 pi is equal to 360 pi. If we divide by 6 pi, we get 60 degrees as our central angle. 10-84 is a multiple choice question. Triangle ABC is a right triangle and is graphed on the coordinate axis. The measure of angle B is 90 degrees and the slope of AB is negative 4/5. What is the slope of BC? So we have our triangle ABC. So if we draw our triangle A, we know that B is a right angle. So if we have A, B, C, I know that B is a right angle, 90 degrees. I know that AB has a slope of negative 4/5. They ask us what is the slope of CB. Well, knowing that these lines are perpendicular, I know my slopes need to be opposite reciprocals. So the appropriate answer or opposite reciprocal of negative 4/5 is positive 4/5, which is B.